All right, so I think I'm going to work through a few of the problems from the homework. So this is on page 317. And I'll see if we can maybe work through a couple of the even numbered problems. And then you can maybe check the odd ones against the text to make sure once we see how that we're doing them correctly. So let's see if we can play number 20. And it says we have a normally distributed population. So we have a normally distributed population. We also have mu is given to be 61, and we're given the standard deviation is equal to 16. And part A says, what proportion of the population is greater than 100. So what proportion of the population, well, we know the population is normally distributed. So we know we get to use the normal curve. That piece of information is given and will be given on all the problems we're working at least for a while. So this is the normal distribution. And we have our two scales. This is the z scale, the standard scale. This is the x scale, the data scale. We know the data scale is centered at the mean, which in this case is 61. I typically write the standard deviation here just so I know where to look to find it for sure. Now, what proportion of the population is greater than 100? So we need to know where 100 is on this data scale. Well, 61 is here, so 100 is over here somewhere. And the proportion of the population that is greater than 100, greater than 100, is given by this region. Because proportion is the same as probability. The proportion here is the same as the amount of probability that lies in this region. So if we want the proportion that lies in this region, that's the same as the area or the probability of finding a data value in this region. Let's just suppose that this works out to be 25%. It's not going to be, but let's suppose this is 25%. Then if you randomly select a data value from this population, the probability that it falls in this region would be 0.25. So the probability of being in this region is the same as the proportion of the population that falls above this value. So it can be worded several different ways, but ultimately we're looking for this probability, we're looking for this surface area. Now, this is what we want to find, and let's word it properly. The proportion of the population is the same as the probability that a data value falls in this region. Probability that the data value, what is this region? This region is greater than 100. So we want to find that probability, which is to say this area. Well, when we draw our picture, we remember this. The arrow doesn't go to the right. The arrow always goes to the left. And so this now becomes our issue. We want to find this probability. And so the procedure by now, I hope, is straightforward. First, translate from the data scale to the standard scale. Now, this formula doesn't need to be memorized, but you will have it learned because you will have used it several times. Substitute the values in. X is 100, mu is 61, sigma is 16. So we have 100 minus 61 over 16. So either put parenthesis around the numerator or compute the numerator, hit equals, divide by denominator. Either put parenthesis around the numerator if you are adept and your calculator is used to working with parentheses, or compute the numerator, hit equals, divide by denominator. So I have 100 minus 61 equals is 39 divided by 16. My value is 2.4375. Do you remember our rule? We always round to the second decimal place. So we will use 2.44. We use the simple rule, 0 through 4 rounds down, 5 through 9 rounds up. So we will use our z-score is 2.44. That goes here in our picture. 100 on the data scale corresponds to 2.44 on the standard scale. All right, so that's the z-score. Now we need to find the table value. .44 in the table. 2.4 is here. I'm going to zoom in. 2.4. The second decimal value is 4 also. Notice I can enter from the bottom because this table is so well designed. 2.44. Our table value is 0.9927. 0.9927. 0.9927. Let's back that back out here again. 0.9927 is our table value. Table value always goes on the arrow, 0.9927. So we have found this probability, which is the probability we don't want. We want this other bit. Well, this is now the same procedure as always. Typically, when you want the probability to the right of the number in question, the table gives you to the left. And so our computation is we need to do 1, the grand total, minus the part we don't want. That leaves us with the part we do want. So we can say the probability that x is, the probability that x is greater than 100 is given by 1 minus 0.9927, 0.0073.